This is the basic example how to create AWS Lambda on Java for Alexa skill. There is the nice guideline how to set up this, and it has nice examples, pretty simple. And we have this hello world with the handler and number of individual handlers. In this tutorial we will go through all details how to set up this environment. First we can create the Alexa skill and we navigate to developer console, login, and select the Alexa section. In your consoles we select skills and create new skill. In this tutorial we will create some simple example when the Alexa respond us with the random number, so we can call them as the dice, and to make it more unique name we'll call this magic dice, and we hit next, and then we select custom and create the skill. And now we need to proceed all those steps to complete the building of this Alexa skills. First we create the invocation name. This is how we will refer to the skill when we ask Alexa. So it would be magic dice. And the next would be intent. Intent is the set of utterances, sentences or requests grouped logically. So this would be one intent in this example, and it would be random number intent. And then we create several utterances how we would request for the random number. More utterances, better model, more precise model for recognize, and then we can build the model. Next we select interfaces, audio player, display, so we use only audio player. And next we need to choose the endpoints where our logic is located. It is recommended to use AWS Lambda, and we will go for this. And this is our skill ID. And now we need to create the Lambda for this. Navigate to AWS console, select section with the Lambda functions, and we have a couple of them, so we create a new one from scratch. Function and runtime would be Java, and we use existing role, and the existing role would be Lambda basic execution, which normally exists already. We can hint the create function, and for this function we get this ARN, which we will put here in the AWS Lambda ARN. And we also need to add to this function trigger. In this case is Alexa skills kit, and it needs to be configured. And configuration is in this. It requires skill ID, and skill ID is exactly this one. So we copy it, paste it here, hit add, and hit save. Function is created. Click on the root node and specify which handler would have the logic, and we need to upload the jar file. We save endpoints, save model, and then we can try to test it. When we open this tab, it requests access to the microphone. We need to allow this skill to be tested. The device log. Skill ID contains JSON for input and JSON for output. It would have the display emulated for the echo show, and it would have some device log. Here we can start asking Alexa. And sometimes this interface doesn't respond, and in this case the reason might be antivirus. So I go to the preferences of antivirus and disable temporary web shield and ask again. And now Now request proceed, but as long as we don't have the lambda function, we cannot get the correct response. I'll turn on the shield again because it would continue working. This is the JSON input, and this is how it requests the lambda handler to process the request. We'll use it in a minute. Next we will need to create the function itself. I'm opening the IntelliJ IDEA community, which is free. You can download it from jetbrains.com site. And this is the community free edition of these different platforms. Recommend to use Toolbox when you have all the products in one place. Now we create the new project. This basic Java project, Java 8, and it would be empty. And then we need to add dependencies. And those two dependencies we need to add: project structure, libraries, Maven. Next dependency would be ESC, SDK. Then we need to create some logic. So here we will create the class which would handle these requests. The name can be arbitrary. Implement on this interface. And this is the handler. This would be the class and this would be the method. And it would get the input stream as the input and output stream where we need to put our answer, and context has some useful things like logger, or it can log the error. This handler is supposed to be part of the lambda, and here we would put this class name, and then we would put the method name. And if we have the package, for example, we can put it to the package. So it would be within this package, and then we need to put this package as the part of the handler. Don't forget to hit save, and then we need to respond with the output stream. We need to deserialize the input and serialize the output. There is multiple IO utils, and we select this one. And we need to deserialize it, and for this we will use Jackson serializer. And then we need to create the response, and the response would be created by the skill. And we will initialize this in the constructor. And we will also initialize the Jackson serializer in constructor, so we don't create it every call of this lambda function. And then we need to put the respond to the output stream. But to create the skill, we need to register some of the skill handlers. Request handler, and it would be such a handler. And I need to implement those two methods, and this method is supposed to specify if this handler can handle this particular input. In this case we always respond true, and this is the response itself, and this response can be built using the response builder. and then we will get this response, and this response would be static for a while, but we can customize it afterwards. We can build now the project. Yes, it looks fine, but in order to put it to the AWS services, we need to create the jar artifact. Go to the artifact, create the jar. From this model, keep this main class empty because we don't have it. Then it also get all the dependencies within the jar file. And I usually also tick this checkbox so every build rebuilds the jar artifact. Build the project, and it also would rebuild the jar artifact which would appear here. Here we have the jar artifact, and I copy the path. Lambda management console, hit the upload button, open this jar artifact, choose the file, save it. The file is saved, and how could we test it? Configure a test event, and for the content of the request we would get this skill IO Jackson input, and we would save it and select this one and hit the test. Now we have this response number is 10. Test it again, number is 10. And now we can test it with the Alexa skills. Maybe we need to reload the page. Probably we and re-sign in. Allow. Number is 10. Now we just got the response, number is 10. Every time we get this request, it is static. And now we can give the random number. And to make it random, we can create this within boundary of 6, and we add 1, so we get the number between not 0 and 5, but between 1 and 6. Page and upload jar. Save it. 5. Test 4. Like this one. All code would be available within this repository. Feel free to use it. In case if we want to test it without uploading the Lambda function, we can create the test for this. here we have some issue. Different versions of the JAX libraries. So here we have the Jackson Core 294, and here we have the Jackson 2.6. I'll remove those two libraries, 2.6, and keep it this one, 2.9, and I need to rebuild artifact. So I remove this artifact from the model, keep the main class empty. See that we have this Jackson 2.9. Take the checkbox, build the project, and when we have this artifact, copy the path, lambda in this artifact, this just created, save it. IntelliJ IDEA plugin connector for AWS Lambda, and it is available in the plugin repository. So you can go to Preferences, Plugins, Browse repository, type AWS, hit the connector for Lambda and install it. And this is validated version, and you also can always find the freshest version in the releases folder. Download the file, install plugin from disk, downloads, open. So it has the release candidates and the most fresh features, and then you need to restart the IntelliJ IDEA. Then you would be able to see this plugin here. You can put it down. And for this particular user, you can see all the functions within this particular user, and Resh, there is the JART artifact already built, so we build it in case it is old. The build artifact is built, available, it is selected, and then we just hit the update, and then it would be updated. So we don't need to log into this web interface, and in run we can get this here and hit run test, and we'll get this number here as well. Here we can have more information, and every time we call this we have these different numbers here. And this allows us to reformat this, and this automatically reformats the output. And AWS log allows us to see all the invocations. We have the log here, and in the log we have the different events, and if we had the errors here, which we initially have, you can see class not found, exception for example. To work with this you need to create the profile, and even more information if you expand this part here. So you can see the role which is used, and when it was modified, and what is the ARN. You can change this. You can select different functions and test them as well. Different regions, different profiles. And it can work over the proxy as well. For this you need to go to Preferences, System Settings, HTTP proxy, and you need to put proxy here. And when you hit OK, and here you see you don't use the proxy, and when you click this sync button, you've got this proxy, and now you can work over the proxy within the corporate network.